construction. And the first thing we need to discuss really will be talking about the climate conditions. This is actually the first thing that you need to think about it as a designer or whoever is working in construction, really, if you wanted to have a successful project, to consider the climate condition. So if you went to your D2L and you went to under the content, under the course lab, let us go there. You have a module for SC labs here. And this is where our lab setups, I'm sharing everything with you here. To download the software, as you know, you can actually click here and download it. So you can actually click here, and this is where it's really easy step. And I say from theory to practice, this is how I integrated the lab here. You're actually working around the sustainable framework, talking about reducing and eliminating as much as you can the environmental impacts. The first thing is land. So where is your project is located? See the first item here, and you can see the life cycle of this project. This is where you can download the climate consultant. Climate consultant is really have a nice graphical interface. So I have downloaded it. As you see here, let me go to my desktop. It's this one, you double click on it. This is version number 6, by the way, just to make sure all of us are on the same page. And you click on it. This is the interface. And it will give you an idea. So the software itself is very easy. It's based on an Excel file. So Excel file, this is where you have a data and inventory of the climate conditions throughout the whole year. And it's measured by hours. How many hours do we have? 8,760 hours. Okay. And also, the data you are going to extract are already done by NASA, right? And we have also Energy Plus. It's a recognized institution done by, and NRCan is integrating all of these tools from Climate Consultant to Ratiscreen and other software. We are using what is called EBW. So these are Energy Plus weather data, okay? And it's done by the US Department of Energy, as you see there. This data will be embedded in the software. And what happened, it will auto-generate a number of plots, charts. We are going over them. And also, I'm going to show you how to do a custom plot. This is your bonus mark. So if you use the auto-generated charts in your presentation, then this is actually you got full mark. But if you wanted to pursue the bonus mark, you need to do the bonus quiz. Make sense? It's based also that the meat, which I like you to integrate and see in your presentation, will be the psychrometric chart. And actually, when we integrate the design principles within the chart, it's called bioclimatic chart. So how can we start? We'll start a new, we'll go for next. Let me bring my flashlight. You just read here, just talk about the hourly data, which I discussed with you here. And also, if you like to, you had the psychometric chart with the mechanical electrical course. If you forgot about it, you can actually go online. This is actually a good, there is a good video and tutorial about it. And now you can start a new project or continue a previous one. So this is our first session. We'll start a new project. Here you can actually use the type of project. Is it residential? Is it commercial, like non-residential? Also, you can select your own units, imperial or metric. Since we are going to talk about the code, whatever, you are using metric. So I'm going to go for metric. Okay, assuming I'm having my project is residential. You guys, when you do your own project, it can be a non-residential. You go for the other one. Makes sense. It still will count. If it's an office building, it still will count. As I said, we are having estimate. This is actually not like black or white. It's just to give you some guidance for design. Okay, I understand. And also here, you select the climate zone. We have California. We are not living in California here. We are going to download a new EBW. Energy Plus website have this free source for us. So we'll click here, okay? And we would like to have the weather data, the weather file. You go for install from weather data. This will open Energy Plus website. As I said, I'm recording it, so I like you to pay attention. Then you'll have all the time really to do it. It's better. And if you missed any step, you can go back to the video. So here, for example, you have the weather data for most of the world countries like here. And let us, I'm going today to look at Calgary. And then you can do your own, for your own, like BC or China, or pick what I recommend really, pick something different than Calgary. So you can actually do a comparison and see, does it make sense for you? It's actually a good experience if you can do this. It still can be, even in North America, like Vancouver have a different climate than Calgary. So let us go here. So this is where you are going to extract your weather file. So we are in North America, Canada, Alberta, Calgary, and we are going to use EBW. Right click. Okay, you are going to copy the link. You go back again to the climate consultant, and here you are going to paste the link. You can download it online, and you can bring it from your device, either ways, right? So I'll just say install. And now you can see all the Excel file data already here. A big summary. How many hours do we have? Do you remember the number? 8,760 hours. Okay, and you can see it divided onto, like, you breaking down into 12 months is here. And you can see this is, in Calgary, we have a number of weather station. We are using Calgary Airport weather station. Please put this in your mind. Where is your latitude is 51. Remember the number and put it as one of your notes, please. Okay. And this is a data resource and the station. All is good. You can see here the monthly means for the global radiation, direct nominal radiation, diffuse, hours, relative humidity, wind direction. If you logged as a tab on top here, this is where you can actually save your file if you want. You can go back again anytime to it. It will save also if you have a custom plot or something. So maybe it's better to save it if you want. Okay. And here, this is a criteria. This is a weather data. Also, anytime we can change the comfort model. I'm going to discuss this in a minute. Here also, if you logged here, you can also, anytime you can change the units from switch between imperial and metric, anytime. You can also change the weather data if you did a mistake. Like anytime you can fix whatever you have inserted as an input. You can also export the weather data as an Excel file and create your own data analysis. Make sense? So all of this data can be in a big Excel file, and you can manipulate whatever you like to do and use in your report. Also, anytime you can print, okay, you can export as a clipboard. Your charts can have them as BNG, right? Are we done? So let us go for next. Here, these are the comfort models that they were talking about. Which comfort model we should use? The first one is California, right? We are not there. If you are in California, have a project there, you can use it. But the standard one, the energy codes that we are going to explore through the course, we are using ASHRAE. So we'll go for ASHRAE 55. ASHRAE 55 is for the comfort, the thermal comfort. The thermal comfort is a term, we are going to talk about it a lot. It's the state of mind, how you feel comfortable indoor. And it differs from one building to another based on the function. If you have a sedentary activity like a classroom, the thermal comfort is different than if you are in a gym. You know the set point of your thermostat? It will be totally different in the gym than here, because there you are exerting effort, you are sweating, so makes sense? And here instead, so this is where we design. Okay, so we'll use ASHRAE 55. We'll go for next. And you can see here, this is the key features of the ASHRAE 55. And you can see here, it's based on your closing, right? If you are wearing a jacket, totally different than the one here wearing t-shirt, like short shirt. And this is where you actually set up your own. We are using the standard, the average here, but really if you are knowing what is the factor you can use, you can actually just change it here. So you can actually do it manually. But so far we are going to accept the default. Okay. Also for the shading, for the thermal mass and so on. Accept all the default and go for next. And this is the first chart, which is very cool. Where is your thermal comfort temperature? The one in gray. See here? And you have, this is the X and Y. So the X will show you the months. The Y will show you the temperature. If you like to see all, really, because you can see here, not all actually the plot, the points are shown. You can actually go to the left, see the menu here. There is fit to data, and you can see all the chart is included, like every date, all the data are included here. What should we look at? Calgary, is it cold or hot? See here the minimum? Okay, you can see it goes for minus 32. And you can go up here, yeah, around 32 to 35, right? And you can see the mean, which is the average there. And you have a low average and design low average as well. Okay. Here is the thermal comfort. Why do we have two? You can see here in winter, this is where you set your own thermostat, by the way. So in summer, you can actually hold up more heat, right? This is why the comfort is a little bit higher, right? You can actually survive. You can survive still with 24. In winter, so you can see here, it's around 21 or 20, okay? This is a thermal comfort zone. How many hours during the year are we within the thermal comfort? These are, by the way, each point or each part are actually a number of points of temperature, right? With humidity. So are we within the thermal comfort? Do you see the bars within the gray? Most of them are out of it, right? This is why it's challenging to design here in Calgary, because it's very cold most of the year. Yeah? Let's go for the next one. Here, they added more data. So you have actually the temperature still. See let me again go for fit data here. This chart show you also what we call it here. So you have the radiation, the direct normal radiation here. And you can see Calgary has, most of the years they have sun, right? See here? So if you are putting in your mind, in your head, that you might use solar panel, yeah, it's not a bad idea, right? So even if you are not living in Calgary, you have another colleague, a researcher working with you from Saudi Arabia or something, when you see this chart, you already can do your analysis and assumption, even if you haven't visited this. Make sense? So from the data only. And then you confirm by having a site visit. What are the reddish lines here? Can you read? And wet bulb temperature. So the dry bulb is the normal temperature that we measure. The wet bulb is the one that actually, when you have lots of moisture like this, when you consider the moisture, right? So do we have a dry or humid climate in Calgary?
Dry.
Where can you find this in the chart? Can you see it in the chart? Actually, during summer, see here, April to October, you have the top here is a dry bulb temperature. This is a wet. There is a big difference between them. It makes sense. It's very dry during the spring and summer, but in winter, it might not. It's more actually, you have more actually humidity. You can see here. This is only from the chart. Also from that chart, you can see also the radiation is huge. We have lots of sun most of the year. This can be different when you actually study another case. This is why I'm saying, please explore another city. See, is there a big difference? This will be actually awesome to see in your research. Let us go for next. This is where actually also the same was the direct. This is for the sun radiation, the range of radiation here. And it's measured by the surface angle, so tilted angle. Right now, it's 0 degree. And you have most. So you have January, and still you have the bar is up, right? And you can see still we have the radiation not bad at all most of the year. You can really, this is if you would like to have what do you call it, solar panel on your roofing. Okay, if you have them horizontal or if you have them tilted up, most of the roofing here are not horizontal, right? However, now we are seeing the switch. Most of the row homes are having flat roof, and this is where you can actually assume how much radiation you can get within the year, right? But if I change it to 90-degree, for example, let's say I wanted to have it, you can see it actually will go down a little bit. Makes sense because these are vertical. Horizontal will have more exposure to the sun, vertical will be less, and so on. Let us just bring it back to 0. They are doing this data assuming that the grass will have a reflection around 20%. We'll leave the default. And as you see on the right here, it will give you a summary per year, which will be nice also to read. Every dot, this is the temperature and humidity. Makes sense? Or these are data collected from Energy Plus. This is the other one for illumination, again, for daylighting here. And you can see we have many potentialities actually to get benefit from the daylighting. Remember the passive design approaches. So actually understand from this chart that it's a privilege to have this data. So you can actually invest in having more daylighting integrated within your design. Again, so this will also show you how many coverage of clouds per year. You can see actually we don't have that much. It's very nice. So you can see here almost around 100%. You can see we have a high range, right? And you have, like, you can talk about clear skies, clear sky, which means you have less clouds and so on. Also, you have them per month and per year. Okay, this brings us to the wind velocity. To make it fun, you can see here the average. What is the average wind we have here? Can you read it? Yeah, you can see here. You can go, if I ask it for the average, you go for the annual for sure, right? So the annual is here. So 4.5, 4.6, yeah. But what if I ask it, which months we have most of the wind? We have the Chinook, right? May, November, right? And we have a good chart. Let us go for it. I'm going for the wind wheel. And this is where you can see really the winds for all the months. This is average. If you want to do it for months, specific months, you can select the months manually. So this is during January. This is during February. This is during March, May. Okay, you got it here? Excuse me. You can actually make an animation and look at them and you can pause. This is where you can see these spikes. You can see here the peak here. You can see it actually, there is actually an interpretation for it. This is where the wind speed. Okay, and the average RH and temperature. Okay, anytime you can pause, you can stop, you can do some if you like, and take a snapshot if you want. And this is how you manipulate this data, right? And make it work well with you in your research and taking decisions. We'll go for the 3D chart. It's like the one that you show you the dry bulb and the wet bulb, but this is in 3D. So this is the months, this is the time per day. And notice here, these are all in blue. And you can see here, this is where the average temperature, so between 0 to 21. Why? Because this is during, like you can see here, most of the time, we don't have that much heat, right? It's a cold climate. If you pick, for example, Azerbaijan or a city in India, you will see this more in red, by the way. So you can see the difference. So far, we don't have that much heat. This is for the dry bulb. You can anytime you can change it to speed. You can see the speed also. So it's actually another way to interpret the data that we have discussed from the previous charts, but in a cool way. This actually also can be, you can actually move them and you can rotate whatever you like. I'm going here to the psychometric chart because this is where I like you really to focus in your presentation. This is the meat of our discussion today. Any design is based on the weather conditions, and the best way to do it to have it in a psychrometric chart. And the psychrometric chart, you already have taken it during the mechanical electrical. This is where really mechanical engineer will design their own mechanical systems. Is your weather actually hot, cold, humid, dry? Let us have a look. Like I'm going to actually just to delete this. So this is a psychrometric chart. When I add the design, these are the bichrometric chart because you have the design. These are auto-generated recommended design approaches that the software will offer to you. So let us look at the dots. So each dot is for a temperature and the amount of humidity, right? So how would you classify the temperature or the climate of Calgary? See here, it's very cold. Is it humid or dry? Where is the RH? All of these curves represent the RH from 0 to 100. Yeah, this is where you hit the dew point rates. Like 100%, this is where you hit the dew points. Yeah. Okay. For example, if you will pick any like city in India, for example, you will have all of these here on top, very hot. And you can see, let us go for display the strategies. This is actually what is recommended. When you look at this one here, you have some of them are 0. You can actually cancel them. You don't need them, right? So you can do them manually by eliminating the small portions. Which one you see the best effective one that the software recommended? It has 56.7%. What is this percentage is for? These, how many hours per year can be treated and like be successfully designed by using this approach or strategy. Make sense? So by only going for heating and add humidification, okay, I can actually achieve a thermal comfort for the occupants around 56% out of the 4,090. It makes sense for you because these are the hours out of the 8,760. So you can achieve thermal comfort for around 4,009, which is good, right? So this should, for sure, you can't avoid using it. You see how the software is helping you? So these are recommendations. So this city needs heating, needs humidification if needed. Okay, and then you can see, remember the chart is for the direct radiation. The next one you can see here, passive solar direct gain, right? Because you have lots of sun. So by doing this, you can actually also include 1,658 hours. Is it good? You can do this manually, or you can go here and check, show what is the software is recommending. So the software recommending this for you. We're not done yet, because what you can see next, they will set up these strategies in according, remember we talked about the 2030 goals and targets? And you will see most of the strategies that we'll see in the next slide is actually linked to the web page of the 2030 movement. So when I say okay, and for example here, the first thing they have recommended is going for passive solar heating phase most of the glass area. And guess what? See here, it linked to 2030. You can read it, or you can click. You will have a nice schematic drawing that you can integrate within your report as well. Give it a second. So this is where they will show you how to achieve the direct gain, glazing, and so on. Remember I told you about the latitude of Calgary? What was the latitude of Calgary? 51. this is the average recommended angle for your solar panels. So typically will be aligned. It can be different a little bit, 45, whatever. It depends on the product, right? Because now you have different product, different efficiencies and so on. Let's close this one. And when I go for passive solar or another one here, it can again lead you for another information that can help you. Also, they might actually integrate also some charts. There is no examples, like most of them will be. Look at the link is here. So when you have the link, you will have more information about it and some nice schematic drawing about it. For example, form from heat for heating and so on. Okay. Blinds, they said no. Okay, so just look for the ones that have the link. But you can see here from this one, you can look at they actually have the strategies, okay, and they have both them, set them in order within the priorities, right? So this is, for example, number 19. When you go back, so this is the strategy number 19. You can see it here. So this is 16 and so on. Number 16, heating. So let us go back here. So 16 here, they don't have, but they said they recommend adding trees. But they said neither confer or deciduous. Why? They shouldn't be planted in front of passive solar windows. And it makes sense, right? Because it will block the sun. You don't want to do this. Any questions so far? So anytime you go back here, as I said, for example, these strategies you can export. You can take a screenshot. You can go for file, right? Print as a BNG if you want, BMB, right? And you can integrate it within your report and your presentation. Okay. And you put it in a document. And yeah, this is what I asked it for. Yeah, I have a question. Yeah.
Just for the percentage. So if it's like the last 60, that's 60% on second, heating from the humidification, if needed. So do they need heating and the humidification 62% of the time or?
Through a year, yeah. How many months is? Because you can interpret this in months, right? And the software is based on hours.
So this is what the best scenario.
No, this is the best thing you do in order to create a seminar. You need to provide heating for the people for more than 6 months, right? Like around 6 months, which is around 4,000. Once you have this, achieve it, you are close to really achieve a successful design. It's the opposite. So you need heating, right? And humidification. How much? For around these hours. If you cover this in your design, check. This is good. You can't avoid it. This is why we have heating system, right? Humidification, it depends. When you say if needed, because it depends. If you are working in a restaurant or a kitchen in a restaurant, it's very humid. It doesn't make sense you are adding a humidification, right? You might actually need to do dehumidification instead.
Where do you find this data?
Which one? Sorry.
Like the 62 days on the chart. Where can we find it?
So you have the numbers here. See here? And you said, and it makes sense. It's during the cold time, right? And when I go to wind, it's kind of you have the Chinook time, right? May, November, so it's here. And then you go for number 2, sun shading. It makes sense. This is close to the when you are in summer. And it's here, number 2. So they align it with the temperature, the average temperature during the year. So this is where you have it, right? During summertime. Okay. So I'm going to go back to your assignment here and go to your lab. I'm going back to your D2L. Go back to your lab. And you have these handouts just help you again. So if you please download this one, and this is a template that you are going to use to conduct your report. So this will summarize everything I was talking about here. What is the objection, like the objectives of this, the software, and here some instruction. If you went home, you can actually practice by your own. You don't, like, I'm just giving you some steps how to use it, okay, and do some analysis. Okay, lab report, as I said, each group will use the software as a design to investigate. So, for example, yours in UK, user just go and extract the weather data from there. Use the EBW file, please. Okay, and you integrate visuals. Some of this chart is discussed right in briefly, and you can add more within your report. Okay. I also added a tutorial. This is actually was done from the professionals themselves, so you can actually read more and investigate more what is the purpose of each chart further in detail if you want. Here is the templates that I asked you to do and complete a report and submit. You just add the lab, insert the city for sure, and province and regions, and you have your names. Add the objective of your exercise. Makes sense. The methodology, which what kind of tool did you use in order to achieve this, which is your software, and your key findings, right? And I didn't leave you alone, like asked you, where can you get the temperature and demand? You just do a brief description, add some markups, right? This is like similar like what I'm doing right now. Just show that you have learned something in the lab. Make it really informative. Add captions, markups, whatever you find it beneficial in order to make your report readable and clear. And the last thing will be a short reflection here from the exercise. Okay, so I'm going to close my recording and I'm going to open the floor for any questions. So just give me a second here.